Once you have your FCO installed in the GC, you need to connect the control box to your network and find the IP address. You can do this by contacting your system administrator or looking at your router or downloading a convenient program like this called Advanced IP Scanner, which scans your network for all the devices. There are two microchip technology devices here. Both of these are FCO control boxes. This is gray, not connected. This is blue, which is connected. So this is the IP address that we need to type into our browser to connect to our FCO control box. Once you have your IP address, you just simply type it or paste it into the browser. And through this convenient web interface, we have the GC Oven software. On the first page is the status page, and this is an overview of the active method, which is called BTEX in this case. We have two FCOs attached. First one has the set point of 120 and outlet of 55, and the second one of 50 degrees. These values come from the individual editors. The editor for FCO1 is through this tab, and this is our 120 and our 55, the name. This is a continuous run, so it's one sample right after another, right after another. The graph is at the bottom, same graph you see here. The editor for FCO2 is a classic FCO where there is a temperature program. And in this one, we have our chiller on, and our temperature starts at 50 degrees, holds for 30 seconds, ramps at 100 to 250, holds another 30 seconds. This could be a multiple ramp temperature program. In this particular example, the run time is 3 minutes. 2D tab is also linked under the same name. All three tabs are linked under a common name. There's no information in here, but this would be in the instance you have two FCOs for two-dimensional analysis with a high temperature valve in between to switch the effluent from the first column to the second column for further separation. The high temperature valve isn't currently available, but the software is. So let's create a new method. This is the active method up here. Let's just pick an empty method. We'll edit it. Let's create a new method. Let's call phthalates. Okay, and let's say we have an inlet temperature of 250 and outlet temperature of 100. We'll call this an extended run FCO where we have an outlet temperature program. We'll start it at 100, hold for 30 seconds, ramp it 50 to 300. And then let's hold it there for 45 seconds to make a 5-minute and 15-second run. We have the graph here. Let's save this. And the same phthalates name is saved also for FCO1. They're linked, but there's no information here because in this particular method, we're not running an FCO1. The same name is in the 2D. Once again, all three of these are linked under this method. We have not changed our active method BTEX. We have just created a new method. If we do want to make this the active method, we just load it, and then this becomes the active method. If you want to link methods together, for example, having an auto sampler in your GC or GCMS, you can use the sequence table where we'll say we're going to run 5 BTEX samples and then 10 pesticide samples, followed by our phthalate method we just created of 15 samples. So the temperatures for BTEX will be loaded. Those 5 samples will be run using the ready signal from the control box and the start signal from the GC. Then the temperatures for the pesticides will be loaded and equilibrate, and the ready signal will be there. Again, the handshake back and forth with the GC. And then the phthalates temperatures will be loaded, equilibrate, and a ready signal will come for these to follow. So you can conveniently link methods together for an automated analysis. On the diagnostic screen, we use this to manually override. For example, I could change this temperature to manually bake out a column. You can turn off and on devices. The parameter page is the network parameters. The DHCP is on. This is where we got our IP address that we pasted in here. Or you can have a static IP address for this particular control box. Back to the status page, as you can see, our actual temperatures are always within 1/10 of a degree of the set points, and this is one reason why our retention times are always incredibly stable. Okay, so just as a quick overview of the software, through this convenient web interface, you change parameters, you change temperatures and times. But the software does not need to be connected to actually run samples. All of this information is stored in the control box, and you only access it to change parameters and temperatures. Thank you very much.